The first chapter of our textbook is about sequences and series, and the first section is about particular types of sequence, arithmetic sequences. Now, a sequence is just a list of numbers, but it's an ordered list of numbers, meaning there's a first number in the list, a second number in the list, a third number in the list, etc. And they go on forever, so we refer to them as infinite sequences. And we usually refer to the numbers as terms. So we can talk about the first term in the sequence, second term in the sequence, etc. Now, some sequences don't have any particular pattern, but most have some pattern, and I don't think it would be too difficult for you to figure out what the pattern is in each of the four examples here. These are all examples of arithmetic sequences. More formally, we can define an arithmetic sequence as a sequence that has a common difference. In other words, the difference between one term and the next is always the same, and we call that a common difference. So let's calculate what the common difference is for each of these four arithmetic sequences. So the way to avoid making a mistake is always just to take any term in an arithmetic sequence and subtract the previous one. It doesn't matter which term it is, so long as it's an arithmetic sequence. So, for instance, we can say d, the common difference, here is, let's say, 3 minus 2, which is 1. So this has a common difference of 1. In the next, again, take any term and subtract the previous one. So if we take 19, for instance, and subtract 15, we get a common difference of 4. And it should be the same if it truly is an arithmetic sequence, regardless of which term we take. So 11 minus 7 is 4, 15 minus 11 is 4, etc. Sequences can have negative common differences, in which case they're declining or decreasing sequences. 40, 35, 30, 25, the numbers are getting smaller. So again, take any term, any number in the sequence, and subtract the previous one. 30 minus 35 equals negative 5. It's a very common mistake to write the common difference as 5 here, just thinking about the absolute difference between the numbers. So very important to take a term, subtract the previous one, and then you won't make a mistake. Almost all of the sequences and series that we will look at are sequences and series of integers. But there's nothing that says that all the terms have to be integers or that the common difference has to be an integer. And here's an example. So if we take any term, let's say 8.2, and we subtract 8.0, we get a common difference of 0.2. And we could express that as a fraction as well, a fifth, and you may see sequences that involve fractions. So let's say we wanted to generate more terms in this sequence. Let's say we start with a sequence like 10, 13, 16. And we want to go a little further. Alright, so we have the first three terms of this sequence. What if we want the sixth term, T6? Well, it's not all that hard to figure out what's going on. In order to go from the first term to the second term, you're just adding the common difference. In order to go from the second term to the third term, you're adding the common difference again. And this is T1, this is T2, this is T3. So if we want to keep on going, we can just keep on adding the common difference. And the common difference in this case is simply 13 minus 10, which is 3. So if we keep on adding 3, we'll just generate new terms in the sequence. So we have 10, 13, 16. Let's add the common difference, 3, and we get 19. Let's add the common difference 3 again, and we get 22. And we'll add the common difference again, and we get 25. So here we have T4, T5, and T6. Now I've used notation that you may not be familiar with. The little subscripts below the T allow us to reuse that letter T. Instead of, for instance, referring to the terms in the sequence as A, B, C, D, E, and then eventually running out of letters, this way we're never going to run out of letters. Every term is simply T with a little subscript referring to where it is in the sequence. T1 meaning the first term in the sequence, T2 meaning the second term in the sequence, etc. And T6 means the sixth term in the sequence. Let's break this down a little bit and see what we actually did. We calculated T6 by really starting from T1. How many times did we have to add the common difference? Well, you can see above the sequence there I've got 5 jumps. So T6 is really T1 plus 5 common differences. And T1 is 10. 5 common differences, 5 times 3 gives you 10 plus 15. Sure enough, we get T6, which is 25. Now, just adding the common difference and generating new terms is fine if you only have to go a couple of terms. But let's say we were looking for the 50th term of this sequence, T50. We don't want to list out all 50 terms, although I have seen students do it on quizzes and tests. The reason you don't want to do it is because it takes too long, takes up too much room, and there's a large probability that you're going to make a mistake. So let's just analyze what we did above here to figure out how we can figure out what T50 is. So T50, if we start from T1, how many times do we have to jump? How many times do we have to add the common difference to get from T1 to T50? Now, it's a pretty common or intuitive answer to say 50 jumps, but let's be careful here. Going from T1 to T2 is actually only 1 jump. Going from T1 to T3 is 2 jumps. And as we saw, going from T1 to T6 is 5 jumps. So going from T1 to T50 is actually only 49 jumps. So we're going to add the common difference 49 times. And in this case, T1 is 10, and we're adding 49 times 3. So we get 157, and that's a lot more efficient than just simply listing out 50 terms. And if we wanted the 500th term, it's not going to be any harder than this. Now, let's just see if we can do this a little bit more generally. If we want to find the nth term of a sequence, we can always start from the first term of the sequence and then add a certain number of common differences. And to go from the first term to the nth term, remember, we're not adding the common difference n times, we're adding it n minus 1 times. When we went from the first to the 50th, we added it 49 times. So when we go from the first to the nth, we add it n minus 1 times. Now, that little formula that I've just written down is called the general term of an arithmetic sequence. That on its own doesn't really tell us too much. What we'd really like to know is the general term for a specific sequence. So let's do it for this sequence that we've been working with. Tn is equal to the first term, which is 10, plus n minus 1 times the common difference, which is 3. Well, let's simplify this expression here. 10 plus, we'll expand that, 3n minus 3. Let's put the 3n first, and then the 10 minus 3 becomes 7. Okay, now let's just break down where each of these numbers comes from. The 3n, the coefficient on n, well, the 3 is simply the common difference. So in other words, as soon as we know the common difference for a sequence, we can just write that number times n. And then how do we figure out what to add or subtract? Well, the 7 came from a little arithmetic, 10 minus 3. But what's 10 and what's 3? Well, 10 was T1, and 3 was the common difference. In other words, we subtracted a common difference from T1. Well, think about what that means. If you add a common difference, you get the next term. If you subtract a common difference, you get the previous term. So if you go from T1 and you subtract the common difference, you're actually at T0, which is called the 0th term. Now, I know outside mathematics, nobody uses the word 0th, but why not? We can call the term before the first term the 0th term, and I will refer to it as the 0th term. So the key to finding the general term for a specific arithmetic sequence is to find those two numbers. First, the common difference, then the zeroth term, and then you can immediately write the general term. And this is really powerful because it's like a formula that allows you to calculate any term in the sequence, no matter where it is. Let's go up, get some practice with that, and do it for the first four that we saw. So let's figure out the general terms for each of these sequences. We already know the common differences, we just have to figure out the zeroth terms. So in the sequence 1, 2, 3, 4, the number or the term that would come before 1 would be 0. So this is a particularly simple one. It's just simply n, right? n plus 0 if you like, or 1n plus 0, which is just n. Let's do it for the next one. We know the common difference is 4, so right away we know that the general term is Tn equals 4n. Well, what's the zeroth term? Well, the one that would come before 7 is just 7 minus 4, which is 3. So 4n plus 3. It's always a good idea if you generate a common general term to figure out whether it works for the numbers that you've got. If you plug in a value of 1 for n into the formula, you should get t1. So 4 times 1 plus 3 is 7. That works. If you plug in a value of 2 for n, you should get t2, the second term in the sequence. 4 times 2 is 8 plus 3 is 11, etc. In that way, you can check very quickly whether it's the right general term that you've calculated. Let's do the next one. The common difference is negative 5, so Tn is negative 5n, and the zeroth term would be 45. So negative 5n plus 45. And finally, let's do this one. Tn equals 0.2n. The zeroth term would be 7.8. So 0.2n plus 7.8. And once we've got the general terms, we can generate any term in the sequence. Now, let's take a look at a quick problem. What if you're given just kind of two random terms in a sequence, and you want to figure out other terms in the sequence? So let's say, for instance, you're given T10, the 10th term, and T14, the 49th. Sorry, T14 is 49. So T10 is 25, 10th term is 25, the 14th term is 49. So this is going to work for any two terms, but I picked ones that were reasonably close together so that we can see what's going on. T10, T11, T12, T13, T14. How many jumps to go from T10 out to T14? 4 jumps. How can you calculate that easily? Well, 14, the subscript for the last one, minus 10, the subscript for the first one, is 4. Right? To go from 10 to 14 is 4 jumps. Just think about it. To go from T1 to T2 is 1 jump. What's the difference in the subscripts? 2 minus 1 is 1. So this is nice because we can now create an equation. We know that if you start at T10 and you add 4 common differences, 4 jumps, you get to T14. Well, we know what T10 and T14 are. This is just 25, and T14 is 49. So we have a nice little equation in D. We can subtract 25 from both sides and divide both sides by 4. And now we have the common difference is 6. Okay, we'd really like to know the general term of this sequence. And so the next thing we need to find is the zeroth term, T0. Well, let's write an equation just like that one I just wrote. T0 plus how many common differences gets you out to T10? Well, the difference in the subscripts, 10 minus 0, is 10. So in other words, you can add 10 common differences to T0, the zeroth term, and you end up with T10. So now I have an equation in T0 because I know what D is. D is 6. So 10 times 6. And T10, I also know that. It's 25. And notice I could have used T14 in this equation if I liked. But you usually want to keep the numbers as small as possible. So 10 times 6 is 60. If we subtract 60 from both sides, we get t0 equals negative 35. And so now we can write the general term for this specific sequence. Tn is equal to the common difference times n, so 6n, plus the 0th term, which is negative, so we can write that as minus 35. And now you can generate any term in this sequence. If you want to find the first term, or the 50th term, or the 500th term, you just simply replace n with 1, or 50, or 500. So for instance, if you want to figure out t1, t1 is just 6 times 1 minus 35, which is minus 29. Now if you're asked to find the first three terms, the easiest thing to do is just get one of them and just keep on adding the common difference. In fact, we didn't really need to use the formula since we already knew t0. We could have just added 6 to that. So t2 is negative 23, and t3 is negative 17. But, you know, we can find t100, for instance. It's just 6 times 100 minus 35, which is 600 minus 35, which is 565. And any term in the sequence can be found in this way. So what I want you to think about, and we'll discuss in class, is how are arithmetic sequences and linear functions related? So recall the general form for a linear equation, y equals mx plus b, and the general term for an arithmetic sequence, tn equals dn, the common difference times n, plus the 0th term. So there's definitely some similarities there, and I want you to think about those similarities, and we'll discuss those in class.